Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. I recently attended the Omicron Diagnosis Week conference this year in March. This particular Omicron conference is held every 2 years and brings together expert users and industry peers to share practice tips as well as to discuss the latest trends and also solutions for power system testing. Knowledge sharing and open dialogue about power system testing topics are very important to Omicron, and it frequently offers such events all over the world. One important topic was addressed as the keynote presentation at this year's conference. It concerns the challenges faced by the power industry in the energy transition and its impact on asset diagnosis. To gain more insight into this topic, I had the honor to speak with the presenter himself, Wilfried Breuer. Wilfried is the managing director of Maschinenfabrik Reinhausen and chairman of the German CIGRE committee. In the following discussion I recently had with Wilfried, he describes the ever-changing energy mix in Germany and how it compares with other countries around the world, the increasing use and impact of renewable energy, the challenges with handling the future energy demand, as well as how the integrated use of the latest offline and online diagnostic solutions, performance management systems, and even artificial intelligence will help operators ensure a safe, stable, and reliable power supply in the future, despite volatility and change in power systems. So without further delay, here's the discussion I had with Wilfried Breuer. Wilfried, welcome to Energy Talks, and thank you for joining us for this discussion.
Thank you for having me, Scott.
Wilfried, could you please describe what does Maschinenfabrik Reinhausen do, and how is it involved with the energy transition and asset diagnosis?
Yes, Maschinenfabrik Reinhausen, or in short MR, well known all over the world, is first of all a leader in transformer tap changer manufacturing almost for 100 years. But aside of the tap changer, we are also leading supplier of transformer accessories, including sensoring equipment, and therefore now diagnosis, sensoring, and also the evaluation of the data is increasingly important for our business.
Very good. Is that worldwide?
Yes, that's very much worldwide. Our export quota is well above 90%. So despite the big boom in the home market right now, there is even a bigger demand, especially currently in the US.
Very good. Okay, so you are also chairman of the German CIGRE committee. Could you describe your role and the focus of the committee's work?
Yes, currently the committee is working on the preparation of the CIGRE Paris session 2024. That means we are selecting the presentations and the contributions from the German authors and working and study committees, making sure they have the right quality and scientific background to be a good fit for the preferential subjects. Aside of that, we are preparing in October this year an information gathering, which we do traditionally every year to get the members updated, but also more visible to interested parties in the country.
Very good. Okay. At this year's Omicron Diagnosis Week conference, you gave a presentation about the challenges for the power grid in the energy transition and its impact on asset diagnosis. I would be pleased if you could share some of this information from your presentation with our listeners.
Yeah, the first key message of my presentation was that given the decarbonization of the world, which in many areas, like for instance mobility, is going to substitute the use of fossil fuels by electricity, that will impact the grids and will make the resilience and reliability of electrical power supply even more important than what it is already today. So we cannot get decarbonized with less reliability in the grids. Achieving reliability, that's then the second message of the presentation. Online as well as offline diagnosis is key because the assets in the grid and grid components are being stressed higher than ever before. And that is why diagnosis is a key element to achieve that reliability.
Very good. So in terms of renewable energy, could you provide us with a brief overview of the electricity mix in Germany?
Germany has already come a fair way towards decarbonization. Currently, we are at around 46% total generation capacity out from renewables of the demand, so the energy demand, not power peak capacity, which is sometimes mixed. However, that means we are still not half than what we need to go to fully decarbonize the power sector. Plus, we expect additional electricity load to come from electrical mobility or heat pumps and domestic heating.
Very good. So when we talk about renewable energy, could you give us an indication, for example, in Germany, what are some of the prime sources for renewable energy?
Yeah, Germany, same as on oil and gas, we are not completely able to feed ourselves from renewables. So the main dominant resources are currently onshore as well as offshore wind. In offshore wind, we have quite good conditions as the North Sea is pretty shallow. However, the space there is limited. Onshore wind is already very well developed, but it comes to the limits of what the society accepts. So renewables, yes, but please don't put the wind turbine up in my neighborhood. And solar has the biggest growth potential according to the latest government plannings. But of course, the infeed of solar radiation in that part of the world is limited. We don't have sun every day, but we have a lot of roofs still to be explored. So that's the three key sources. However, it will not be sufficient to feed the energy demand of Germany, which is currently around 2,300 terawatt hours. Even if a reasonable maximum installed base is available, we will still need either green electrons or green molecules to be imported to feed our energy demand.
Interesting. So thank you for that overview about the electricity mix in Germany. Would you say that this mix is similar in other regions of the world?
No, I think the energy transition is something you need to be looking specifically country by country. There are luckily countries which will be net exporters of renewables, like a lot of states which are in the solar belt of the globe. They can produce excess energy, excess renewable energy, and then become exporters. Other countries, like our neighbor France, is opting for nuclear power to continue nuclear power, which will change their generation mix, of course, in a completely different way compared to Germany. So if you look at that topic, you have to look at really country by country. And what are the natural resources, what is the political direction, and how fast they are developing on that roadmap.
Very good. Okay. So renewable energy, as you said, is contributing a growing percentage to the electricity mix. How does the volatility of generating renewable energy affect system balancing and loading of critical grid assets?
Yeah, especially returning to Germany, the renewables are largely weather dependent, except a bit of run of a river hydropower, which will mean there is a high volatile loading in the grid. The grid operators will need to do a much better job in terms of load balancing. We will need interim storage facilities, and that in result will also impact a higher volatility on the usage of grid assets, like, for instance, transformers.
Very good. So how do power grids need to be restructured in the future to meet these challenges? What technological solutions and requirements are needed for installed assets?
Yeah, first of all, we need a different topology in the power grid, because the power grid, as we have it still today, largely was designed to deliver power from central power stations to nearby load centers. So we had the major industrial loads close to the generation, and in the future, renewables are more remote from the load centers. So that will require a physical change of the grid. We will need more grid on all voltage levels. At the same time, speaking on the higher volatility, we also need a smarter grid. That means we need to digitize the critical assets in order to allow a good temporary overloading. This is already very much applied, for instance, in a technology called dynamic line rating, because if it's cold outside and the wind is blowing high and you get good revenue from the wind turbines, you can overload the transmission lines. And by measuring the wind speed and measuring the ambient temperature, you can calculate exactly how much overload you can allow. And using that example, which is already very much in play, that will be expected for a lot more assets in the grid.
Interesting. Okay. What challenges does the energy transition present to power transmission systems, especially when renewable energy sources are not generated close to load centers? You mentioned, for example, offshore wind,
Yes.
which is far away from where you actually need the energy.
Yes. One thing to mention would be the usage of high voltage DC technology, which was a technology delivered from Germany to many other countries for decades. But now it is being applied in large scale also within the country to build so-called electricity highways. That is a complete demand by the energy transition, connecting remote renewables like offshore wind, using submarine cables over hundreds of kilometers to connect to load centers. So this is an example of a complete new asset class technology in the heart of the electricity system and to build new backbones.
So that it really enables energy to be transmitted over long distances then.
Right. Germany has a bit the topographical challenge that wind power, which currently is the dominant source of renewables, is dominantly in the north, while the load centers are in the south. And to connect these over longer distances than before, HVDC is efficient and economical technology.
How will transmission grid expansion in the future meet these challenges? For example, in Germany, what is or will be required?
The process in Germany is that every 2 years, the transmission system operators calculate based on a government-sourced scenario framework the grid development plan looking 10, 15 years ahead. So there's a master plan being updated every 2 years. And for the last 10 years, this master plan has been ever increasing. So every 2 years, the amount of new transmission lines or transmission assets to be upgraded is increasing compared with the previous one. The latest one, looking forward in 2037 and 2045 respectively, was just released 2 weeks ago from the time we have this interview.
Well, that is quite some time in the future.
Yes, and it sounds like it is a long time in the future, but given the long permitting time we need to get the construction clearance, that time horizon is necessary to have these assets really commissioned and operational at the time. So the average time between calculating the need for a new transmission asset and having it in service, be it underground cable or overhead line, is roughly 10 to 15 years.
Wow, I wasn't aware of that. That is quite a bit of planning there. What are some of the challenges with renewable energy faced by distribution grids at medium and low voltage levels?
Yeah, the distribution grids in the past used to be rather non-smart. They were over-dimensioned in a way that they were always sufficient to feed whatever load is at the end of the line. And they did not have a lot of measuring or sensoring equipment to give the operator a real feedback of loading. Now, most of the renewables, specifically roof-mounted solar, is connected to the low-voltage grid. Heat pumps and electromobility is basically completely connected to the low-voltage grid. We will see, and we see it already today, bidirectional power flows. The low-voltage grid was never designed for that. It was always a unidirectional power flow from the transformer to the consumer. Mm-hmm. Today, we don't have only consumers, we have prosumers. Their rooftop solar system overproduces when the owners is in daytime at work and is not using electricity at home, but his solar system is feeding back. All these are challenges being faced in the low-voltage grid, which probably doesn't see these huge mega projects like HVDC connecting to offshore wind, but in the total sum of the whole country is probably the bigger challenge in the whole transition.
How to balance everything.
How to balance, and also the high investment volumes. The low voltage grid will need to be physically upgraded. It will need extra capacity to deal with these additional loads and infeeds, and it will need to be made smart to deal with the bidirectional power flow and to achieve through a level of controls and steering a stable power supply as we used to have it in the past.
So actually it means more responsiveness.
Right. The high voltage grids have been smart even before the energy transition started, but the low voltage grids have to be upgraded and to be made smart. So that's the extra challenge on the low voltage grids.
Wilfried, could you please describe how all of these challenges are making it more difficult for power grid operators to ensure safe, efficient, and reliable operation?
Yes, for power grid operators, and I used to work there before joining MR, so I do have an insight there. The life has become really much less predictable compared with the past. In the past, maybe power business was even sometimes considered a dull business compared to selling mobile phones or developing something with 2 to 3 years product life cycle. But I would say now the power industry and especially the grid operators are in a similar environment of permanent adaptation of even stringent goals. We just saw a year ago in Germany with a new administration coming in, a new set of targets for 2030. And from today to 2030, less than 7 years is a relatively short time to react within a power grid. So life there has become very challenging. At the same time, I would like to add the challenge that experienced and seasoned workforce is retiring in a bigger scale than new people are available for the market. We have insufficient number of students completing engineering courses, and so the fight for the right skills and competencies will be an additional challenge for the grid operators in the future.
What diagnostic solutions are available to help power grid operators now and in the future to deal with the challenges you had mentioned and also to anticipate what is to come?
Yes, diagnostics are not entirely new. They are around since 20 years, but diagnostics in the past were always seen as getting data for a human key expert to take certain decisions on assets or to the control room operator how he can use the grid. Yeah, they had a good feeling based on experience. Mm-hmm. In the future, the complexity of grid operation will increase because of the energy transition. We discussed that before. And at the same time, we will have less and less experienced colleagues who run these systems and take the right decisions based on experience. Diagnosis, therefore, has to become smarter. So diagnosis just not has to deliver reliable data, but it also has to evaluate the data. So we need to put a part of the experience and smart cleverness of seasoned operators into the algorithms of what is nowadays called artificial intelligence. So that's clearly a step forward for diagnosis, that diagnosis is more than just a comfortable measurement and acquisition of data, but that it also gets an initial evaluation and gives you support. And eventually also it will share data with others through cloud-based solutions so that any operator will benefit from operational experience made anywhere in the world.
Very good, interesting. So what are some of the newest technologies for offline and online asset diagnosis which will aid power grid operators in the future?
Yeah, coming from MR, I would like, of course, to mention our vibroacoustic measurement, which is an acoustic sensoring of the tap changer operation. In the past, tap changers were monitored predominantly by torque supervision of the drive unit. So if the torque increases during operation, that's a clear sign that something is not as perfect as it should be. But not all the abnormalities could be detected just by torque measurement. So with an additional vibroacoustic measurement, which is very small and almost invisible, so we can have a very small sensor there installed, we sense any potentially loose screw, washer, or any noise which is during the operation in the system, an early indicator for a potential failure, much better. And therefore, it's a step towards a risk-based maintenance so that you just make the repair and maintenance 5 minutes before 12.
Interesting. This is a well-known solution, developed relatively recently, but is it catching on around the regions that you're dealing with?
Yes, it receives a good response. Transmission asset operators are traditionally very conservative. So they are not like buyers of mobile phones going queuing in front of our shop to get the latest version on day one. So the typical market introduction, what we see now is that there are maiden pilot installations being done by almost all customers along with new tap changers, but that they will now take some time for evaluation. The performance, does it give the extra information? Is it worthwhile the additional tech on the order sheet? And does it give them the additional operational safety that they are hoping for? So we are now in this phase where many customers have opted for it, but evaluating the first years of experience. And challenge there is, of course, the tap changers do operate very reliably. So the number of incidents where you can say this one has saved me from a fatal failure in a young system is relatively remote.
So it definitely takes some time.
It takes some time, yes.
Wilfried, I understand that these solutions were developed through a cooperation between Maschinenfabrik Reinhausen and Omicron. Could you please describe this?
Yeah, that's right. And thanks for asking, because it's a real good collaboration. Online and offline diagnosis are both essential. It's not either or, it's we need both. The online monitoring, like with the vibroacoustic measurement, delivers an early warning, delivers an indication there is something abnormal, stop and take a closer look. It is important that this online monitoring is done in a very economic way, and it is also reliably. If it creates too many false alarms, it will achieve the opposite of what it should do. Once you get a warning from a real reliable online monitoring, which is the MR solution, like vibroacoustic measurement, then of course you need the accuracy of an offline monitoring and diagnosis, which is Omicron's strength. And the key of the cooperation is that we have an aligned data set. So basically the offline measurement using the Testrano 600 will create the same data set offsite to be compared with the online monitoring from our vibroacoustic measurement. So it is basically then a comprehensive, complete measurement.
Very good. So you have a bit of benchmarking there as well that you're able to compare future measurements with.
That's right. And of course, we want to build confidence for our customers. We want to make life easy for the operators and the field service engineers so that if they do the measurements and compare the measurements online and offline, that they don't have to calculate different currencies, if you use that example.
Very good. Now, this whole concept of the vibroacoustic measurement is really fascinating. Could you tell us more about how this is benefiting transformer diagnostics, especially when combined with the dynamic resistance measurement?
Yes, of course, the vibroacoustic measurement is not perfect and will not sense all kind of failures. But with the dynamic resistance measurement combined, we believe, which is a typical offline monitoring and diagnosis, we can get a very comprehensive, complete picture of the status of the transformer with having these two combined.
Very good. So, Wilfried, how do or will performance management systems and artificial intelligence help asset operators gain actionable insights to meet the increasing challenges of ensuring safe and reliable operation?
Yes, as I mentioned before, the key to improve the algorithms is to share the data. Of course, data sharing is a sensitive topic among operators of critical infrastructure, but asset performance management would allow to have, if it is online accessible, to use the anonymized data of all the users to continuously improve the algorithm. And that will then help all the users subscribing to this asset performance management to get an ever better predictability of the data gathered through the online and offline diagnosis. So it's basically a sharing pool of experience which grows by the number of users and over time. And of course, some operators may also opt for having the asset performance management islanded and run it on their own servers for data protection reasons because they don't trust maybe the anonymization. But both is possible, and I think the customers in the world will decide which way they prefer. But principally, these performance and these digital models or digital twins gain accuracy and predictability based on data. The more they are being used and the more data and experience they are being fed with. And I believe the world will need that because of the retirement of an experienced workforce and at the same time increasing complexity, the more and more assets being operated at critical limits.
Very good. So it's really the key words there are the ability to make actionable decisions based on the information available and an ever increasing pool, but not necessarily reliant on a lack of knowledge in the team.
Yes, my vision there is that the systems are not taking away the decisions from the human asset managers, but that they will make strong recommendations based on the evaluated data, based on best practice, based on experiences and records they have seen in other similar data sets, and that these decision proposals will support the asset manager to make decisions faster and more reliably, and building basically on experience made anywhere else, not even necessarily in his own visibility.
So actually, you had mentioned that there's a drain in the knowledge pool anticipated for the future, that really will not be so much of an issue when you have so much data sharing going on.
I think data sharing and making these systems smarter and increasing the prognosis accuracy of these models and of asset performance management software will help to ease the issue. We will still need very experienced people to run the grids, to run the control rooms, to make the asset decisions. Finally, I still believe there will be an asset manager deciding, is it now time to buy a new asset, or is it still a good deal to repair it and have it good for another 10 to 15 years?
Wilfried, in summary, how will the integrated use of offline inspection data and online monitoring sensor values be most advantageous to power grids to meet the challenges of the energy transition?
In summary, it should support the operators to have a clear assessment of the status of the assets. Can I overload it? Can I operate it higher than the limits because it is required in a special situation to keep the lights on? How much is the lifetime consumption if I now overload it in a certain way for a certain duration? All of these answers should be given by a smart online and offline diagnosis. For the asset manager and for the maintenance people, once there is an abnormality recognized and the system is being shut down, the offline diagnosis should present a very accurate picture of what is wrong. So if I know already what is likely wrong from a very good comprehensive diagnosis, I have the right tools, I have the right spare parts, and I can minimize downtime of critical assets. So combined, it helps me for a much better efficiency in the grid, less downtime, which result in more reliability of the overall system to the consumers who expect the lights on 24/7.
Definitely. Wilfried, thank you very much for joining us for this discussion in this episode of Energy Talks.
Thank you very much. It was my great pleasure to be here and answering these questions.
And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Also, if you like what you hear and have not done so already, please be sure to subscribe to Energy Talks on your favorite podcast platform to never miss an episode. Omicron has several years of experience in power system testing and offers you the matching solution for your application. This includes the innovative solution developed by Omicron and Maschinenfabrik Reinhausen for vibroacoustic measurements on transformer on-load tap changers, which was described in this episode. For more information, be sure to visit our website at OMICRONenergy.com. There, be sure to look under applications to find matching Omicron solutions. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.